Hi, I'm Charlie Lalonde. I'm project manager for the Thames River Phosphorus Reduction Collaborative, a group of organizations ranging from farm organizations, a drainage community, conservation authorities, as well as cities working together with the drainage industry to look at how we can reduce the phosphorus level in our waters.
We're very gifted in this area with the land. We are quite capable here of 300 bushel an acre dry corn. I've done it 3 times in the last 5 years. There's seed corn right here on the right. You see the different heights of corn. That's your male and your female. If you look at the seed corn, you'll see most of it is in 4-row female, 1-row male. You also have interplant. This is our farm here. So I've got barley here on the back for isolation. I'm using for feed for laying hens. That's seed corn there. That's pride. And that seed corn right beside us is both the same variety.
This project was excavated in the winter, and you can see on the edge there kind of where the vegetation line is. That's about the fluctuation so far in the water. Like, it's come up pretty high, it's overflowed, and then it's kind of receded a bit, you know, due to evaporation and maybe some seepage as well. Another important aspect of these wetlands is water table recharge, right? So if we don't have these areas and everything else is being drained right to the lake, our water tables keep sinking lower and lower. So it's good to have these recharge areas, especially in the upland areas. Like, this is pretty close to the lake, but on the upland, on the ridge, it's very important to have those areas where you can have wetlands to recharge that water table to keep it up. The clover allows the water to penetrate. It shades the ground, keeps the soil moist for longer. We also underseeded this with pollinator mix as well.
This is project site number 56, okay? I think we're at about 59 in the Rondo watershed now. We do about 5 to 6 projects a year like this, capturing the ag runoff, benefiting aquatic and terrestrial habitats, working with partners, and it's been very, very successful. So build it and they will come. The vegetation shows up, the tadpoles, the frogs, the amphibians, the birds, etc.
The site is about 50 acres, and it runs from New Scotland Line, which is the concession to the south, right up to Talbot Trail. So it's quite a long corridor, and for years they had cows right down in the creek. This went on for 20 years, and people used to call us all the time, say, can't you do something? Got to get the cows out of the creek. Here's the site right on your right here. So if you can picture cattle right down in that creek, causing a lot of erosion, manure going in the water, it wasn't really a good situation. And here's the other side of it too on your left. So there's a program that's been going on for about 10 years in Norfolk County. It's called the ALICE program. That stands for Alternative Land Use Service. In Norfolk County, it's a successful program going on for 10 years. So we thought it was a good time to do kind of a pilot project here. We excavated out on the left there. That's a man-made pond. That woodlot off in the distance you see there is considered a provincially significant wetland. The upland areas, we did plant tall grass prairie, but prairie is a really good method for holding soil together. Some of the roots on big blue stem grass, for example, the roots can go down 18 feet into the ground. So really good at slope stability and controlling erosion. And again, pollinator, lots of wildlife habitat here. Pretty neat site.
My program I'm not interested in trying to take good farmland out of production, but a lot of farms have land that really isn't good farmland for a variety of reasons. It may be hard to access, it may be a small cut-up field that was worth farming 30 years ago, but the machinery's too big to even get in there now. Those are the areas where there's opportunity to create wetlands and hold on to the water longer.
We started taking grab samples in 2016, and then we got our automated equipment installed in early 2016, around March. And we've seen this pump run from an hour, and we've seen it run up to 72 hours at a time. So like we said, during that high rain events, it's pumping for 3 days at a time. And that's when we'll sort of program the sampler to start taking samples at 3-hour intervals, so we get capture the whole event. Later on in the project, we're going to start calculating the nutrient loadings with the velocities and total flows and the concentration values of each event.
So for those of you that are local to this area, you may remember on March 8th, we had a big windstorm occur. And essentially we had an unseasonably warm winter, so there was no snow on the ground. It was warm a few days leading up to it, and the soil really dried up. So the granular soils were very erodible, and we got essentially wind coming from the west that ripped in and caused a big soil plume. When we experienced our next rain event, was essentially a big spike in the concentrations of total phosphorus, organic phosphorus, pretty much every nutrient really, right?
Yeah.
So here, this big spike was the first rain and pump event after that big windstorm deposited all that soil in the drainage system, right? So after that, we saw the largest concentrations we've ever seen out here from samplings.